done. Like we release a lot of things in AWS, and I used to be on the API review board, but I was a little too harsh, so they kicked me off. And I'll be the first to say, like, we like to get things out the door. We like to get it in the hands of customers so we can collect feedback. That means things aren't always so polished. SageMaker came out, and it was like a diamond. It was just beautiful and elegant, and like everything about it was just nice. And I'll talk more about it in a moment. But and then at the bottom level, we have the AWS Deep Learning AMI with Ubuntu and all the different frameworks built on. If you're ever trying to hire for machine learning and someone says they know like Cafe or Cafe 2, you can end the interview there and just be like, okay, you're hired. But we have Cafe on there. And Chainer is a framework that I've been playing around with recently. I really, really like it. Has anybody else used Chainer? All the documentation is in Japanese, so it's a little difficult. But I think they're working on that. Like it's like Nginx, all the documentation used to be in Russian. And now everyone uses Nginx, and the documentation isn't in Russian anymore. Say again?
Can you use Translate or something?
Yes, you can. So you could use Translate to translate documentation. But Chainer is really, really cool because the way most of these frameworks work, things like MXNet and TensorFlow, is you define the network and then you push the data through the network as a separate step. With Chainer, you can, and TensorFlow has a couple of different steps where you can kind of like insert data in as part of the process. But Chainer, you can dynamically change the network over time as you're training. So it's not, the topology of the network that you're designing is non-static in Chainer, which is just like mind-blowing. And it's really, really cool, and so you like wrap your head around it and you just kind of like build these chains. And then Keras is kind of like an abstraction framework, so you can actually use Cafe or TensorFlow, or is TensorFlow not on here? Oh, it's right in the middle, sorry. A giant blind spot. So you can use TensorFlow and MXNet and some of the others with Keras as kind of like an abstraction layer. So Keras is really, really nice. I like it a lot. And SageMaker, you can use all of these. Now, what is SageMaker? It's kind of 4 services in one. So the first service is a Jupyter Notebook service. This is a hosted Jupyter Notebook that has all of the various frameworks and stuff already installed on it. You can spin this thing up. You can spin it up with a GPU, without a GPU, doesn't really matter. Unless you're trying to chain with a GPU, and then you should definitely put a GPU on it. And it has all the frameworks pre-installed, pre-configured, and pre-optimized. On top of that, it's like an AWS instance, so it's like a native thing that you can run in AWS, and you get all the other niceties that come with AWS from that. The second service, kind of like the middle service, is the training service. So you use your Jupyter Notebook to do your EDA, your exploratory data analysis. You kind of play around with the data. You're opening up pandas, and you're looking, visualizing stuff with Matplotlib, doing all that good stuff. And then you're like, okay, cool, I know what the problem is. So now I want to train something, I want to build something. I think this thing is like, sorry, keeps falling off, I'm too energetic. So the training service is straight out of this world. Like it's just super, super cool. And the way that this works, if you have an existing, I have slides that goes through all of this. Again, I got flown in to like cover for people. So who cares about the slides? I'm just gonna explain. So, okay, the way that the training service works is you get a Python SDK, an open source Python SDK, the SageMaker Python SDK. It's on GitHub, you can go look at it. Let's say you have TensorFlow, let's say you have an MXNet, or one of these other services, you have a script that you've been running locally on your machine. Now you want to take that same script and you want to run it in SageMaker. Okay, the way that you do that, import SageMaker from SageMaker.TensorFlow, and then you pass in your script. Like that's it. And it'll run in SageMaker, it'll create a Docker container that will scale across multiple instances if you need it to. All kinds of good stuff. It's just like, when I first started playing with this, I was amazed at how easy it was. And then you have something called automated hyperparameter tuning. This is like an area of active research, so I think ours, obviously I'm biased, but I think our version of the hyperparameter tuning is significantly better than what you'll see in a lot of other frameworks. What this does is it runs a bunch of different training drops and finds the correct hyperparameters for the highest accuracy. The way that SageMaker works too is you actually save every single model you ever train unless you explicitly delete them. And they just get stored in S3. There's a reason for that. A lot of times when you're training, you're using an optimizer like Atom or stochastic gradient descent, and you're trying to find these peaks or these valleys in the curve. And it's like a multi-dimensional space. So like your intuition about like finding Newton's method works in 2 dimensions, but when you get into like crazy 13,000 dimensional space, like your intuition about which direction to move, you can't visualize it. So don't try. I spent a solid like 3 days trying to wrap my head around this, and I was like, no, I give up, because like your intuition about how things move in this higher dimensional space is just like totally wrong, because it doesn't work like 3 dimensions. So you have these optimizers that are mathematically provable and correct, and they're basically trying to find these values in your data set. And the way that works is sometimes you get stuck at a local minima, and you have to crawl out of that local minima and then go back down in order to get into one of these valleys again. And hyperparameter tuning will save all those models, and if you get to a later epoch and you find out there's like this other valley in this dimensional space, it can go back to that other model, pick it up again, and start training again for more epochs until it gets out of that valley that it was stuck in, which is really, really cool. And the way that this works at its core for the like super machine learning people here, this is a naive Bayesian classifier. It works across categorical parameters and like real number lines. So you can basically take any sort of float, like say learning rate, for instance, and modify it. I think it's really cool. Okay, so, and then you have hosting. And having worked at a company where we had to host a machine learning service, the thing about hosting machine learning services is you're not just monitoring the things that you would typically monitor for a web app, right? Like you would watch memory, you would watch CPU, you would watch I don't know, all manner of other things. With hosting services, you're also trying to determine, or with hosting ML services, you're also trying to determine how accurate the model is. You know, is it solving the business use case? And then you have to do incremental training. So it's like, was this result that we served to the user one that was good? In that case, great. Was it bad? Okay, well we need to take the user's input and put that into our next training session. And SageMaker supports all of this kind of incremental training and cool stuff like that. Okay, so in fact, I think we released an incremental training update just yesterday. There is a question in the back first, and then, yes?
You say the model for the later stage whenever the data changes, you use that model instead.
Yes.
How many models can store like that? Based on the number of
the hyperparameter tuning job, it's the number of jobs that it runs, that's the number of models it will store. And you can have it so the question was, how many models does it store, SageMaker? SageMaker doesn't really have any limits. All the models are stored in S3, so you can, you know, a couple 100 million petabytes or exabytes, you know, whatever you want. Like you can have as many models as you want. You just, you know, keep blindly swiping your credit card.
Is there a benchmark for the tuning parameter changes?
Is there a regimen?
Any benchmark for the parameter changes for using different models?
Yeah, so I can show you hyperparameter tuning if you want. The way that it works is you define an objective metric. That objective metric could be like area under curve, or it could be like, you know, accuracy or like whatever kind of thing you want. SageMaker, we'll hop over here, we'll create a hyperparameter tuning job, and I'm just gonna call this NYC locked demo job. Training job configuration. And this is the other part of the service, is we have a bunch of built-in algorithms, which is what I'm supposed to talk about next. The built-in algorithms I will dive super deep on in the next session, but they're straight dope. Okay, so yeah, we'll do object detection, and then you can see all this is just a regex. And this regex or regex, I don't know how you want to say it, regular expression. Regular expression is basically grepping through the logs to find like the entropy, the progress, the fit, and the throughput, all these different things. And you define one of those as your objective metric. So you say like, we want to maximize this, minimize it, whatever. And then you can start out with this is just, these configurations are specific to the type of thing that you're trying to train on. So for this case, which is object detection, we can start with ResNet, or we can start with VGG, which I think is Inception. I can't remember what all the model names are anymore. And you go through, and you basically say, okay, well, this is a real number line value or a continuous value. This is a categorical value. So maybe I want to use ADA, maybe I want to use ADA delta, or stochastic gradient descent. And then you go next, after you do like the number of training jobs you want to run simultaneously. So the number of training jobs you want to run simultaneously, that parameter is always there. And one will get you the best result, but it will take forever. So you could really just do like 50. And it would run 50 jobs simultaneously. Don't do that though, because it's very expensive. Or do that, I guess. But like you could do like 2 jobs simultaneously, and it would run them all. The thing is, when you run all these jobs in parallel, the number of chances you have to make adjustments is lower. So while the time that it takes to train the model is lower, typically, it can also be that you don't reach the best model because you're having fewer chances to make choices in the right direction. So you have to go back and start with one of those other models again. That makes sense. Yeah. Yes, there was a question.
Yeah, you had a selection there for custom. What
Yeah.
does that mean? Does that mean you bring in your own Keras model? You can hyper?
Oh yeah, no, like the way that this works, yeah, any kind of model you want, the way that models work in SageMaker, they're just Docker containers. So the training stuff, you could put whatever you wanted on it. The hosting stuff, you could put whatever you wanted on it. It's really just a hosted Docker container. The cool thing about it is that it can deploy these containers to like 1,000 instances to train if you want. Here's a dirty little secret about machine learning that a lot of people don't know. When people talk about distributed training and everything, it's mostly all a lie. Having worked in distributed systems for a period of time, I will say like creating one node that's like a leader node and calling it a key value store, that is not centralized training. That is not like distributed training. Like the way that all these frameworks work is they advertise, like if you look at the marketing copy, it's like, yeah, we have this grand distributed training data set. What TensorFlow does is you elect a leader node, and that leader node becomes a key value store for all the other nodes. It's not a good, like you're basically taking one of your training nodes out of the equation. And MXNet and all these other networks do the same thing. So we have some stuff at Amazon that is truly distributed. And I will talk about that now. Yes?
Instead of targeting actors, can you target specificity with probabilities?
Yeah, it's what you can target whatever you want. The built-in algorithms, if you want to target something that's not in the UI, you have to do it. You have to like program it through the API. You have to like say like I want to create a separate regular expression to target this thing, and that could be your new objective metric. It's whatever logging output you put out from your training. So long as you can write a regular expression to extract that, you can use that as part of your hyperparameter training. Yes.